So, good evening, friends. After some break or some long break, and after sharing a very good video of Kurt J. Mangal with the very honorable professor on simple explanation of gravity, I have some new idea. I may be totally flawed, it may be totally incorrect, but I want to portray things in a very simplified manner. For that, I will take very simple assumptions. Simple assumptions are that first assumption is mass and gravity. First proposition I want to make: mass and gravity is nothing but a manifestation of trapped light. Light trapped in space creates mass and its associated gravitational field. Second proposition is that reversible flow of light within a region actually creates average properties of mass and gravity. Third proposition I want to make is that as we are in live interaction, third proposition is that energy trapped in mass on an average, that is portion of light trapped in mass on an average, and portion of the light trapped in the associated gravitational field has some ratio. Fourth proposition is that atom is nothing but energy conserved in space-time. That means with changing volume of atom, energy distribution inside that volume, that is inside the volume of atom, energy distribution changes, but overall at any point of time any energy distribution may be different in atomic space, and atomic space itself may vary, but amount of energy or light trapped inside the atom is always fixed, and this we mean by energy conservation. Similarly, since energy conservation is strictly followed in the atomic volume, which is varying space with changing energy distribution, of course, but energy is fixed, surrounding space outside this atomic volume have energy in the form of gravitational field. But we talk of this gravitational field in terms of average. That is, atomic volume is changing, energy distribution inside the atomic volume is changing, but overall energy inside the atomic space is strictly conserved, but surrounding space, that is space associated with gravitational field around this atomic volume, have an average energy distribution. That is, we are seeing the atomic volume for our gravity calculation as an average volume, although in reality volume of atom is changing every second. Energy distribution inside this volume is changing every second, but on an average we can have some average volume and we can have some average energy distribution inside this average volume, and that means, and this energy distribution multiplied by this average volume gives total energy E of the atom. And seeing this around this average volume, we have average gravitational field. Gravitational field is always realized in gravitation in average term only. So surrounding this average volume of atom having total energy E, surrounding space has average distribution of gravitational field. Now, what quantum physics is doing, whether we use Schrodinger equation, Dirac equation, or we have developed on Facebook Bohr Dirac equation, Bohr Schrodinger Dirac equation, all these things. In our theory, distribution of energy in the inside the atomic volume changes. So quantum physics is all about distribution of energy in the varying atomic space with the condition that energy is strictly conserved at every moment in this atomic volume, although atomic volume may change, although energy distribution inside the atomic volume may change, but total energy is conserved. So quantum physics is all about calculating energy distribution inside the atomic volume. That is figure out what is the energy distribution in this changing atomic volume of atom, of course with the limit that total energy inside this changing volume of atom is conserved. That is, wave function whether Schrödinger-Dirac or Schrödinger-Dirac equation, Bohr-Dirac equation, all these things. Wave function in our theory reflects distribution of energy. So of course, integral of wave function multiplied by its conjugate over the atomic volume will be fixed, and it should be proportional to total energy E of the atom. Now this energy distribution, which is changing with space and time inside the atom, is given by basically Schrödinger equation, or in relativistic term Dirac equation, or Bohr-Dirac equation. But for calculation of gravity, you need to calculate total energy, because gravitational field depends on the total energy A of the atom. So for calculating total energy, we have energy distribution equation which will give wave function as a function of psi, as a function of x, y, z and t, and psi will represent energy distribution in space and time. So integral of psi over this atomic volume, or if complex entities are involved, psi multiplied by mod of psi around this atomic volume, it should be related to not only probability distribution of one, but in most general sense, integral of mod of psi dv or mod of psi ka square dv or integral of psi dot psi complex dv over atomic volume should be proportional to energy of the atom. Okay? And energy of the atom should dictate curvature of space and time. Curvature of space and time can be calculated or predicted according to Einstein's general relativity equation. According to general relativity equation of Einstein. That is, integral of psi dot psi conjugate dv should be equal to or proportional to total energy E of the atomic volume, and this should be proportional to space-time, average space-time curvature inside the atom, and this should be proportional to space-time curvature just outside the atom. I need a copy and pen. Rima, give me copy and some sketch. What I want to make the point. What I want to make is a point is that I have very simple model. Please give me only 5 minutes. That is gravity or gravitational field.
ये लो पेन है कॉपी है स्केच लिख के
Okay. I have some vision problem. That's why I found it very difficult to understand general relativity of great Einstein, and its very complicated tensor equations. So I am changing the screen. Rima, give me sketch if it will be better. Okay. So suppose first we have to define the atom. Suppose this is the light. Okay. This is the light.
ये लो भैया स्केच
ओ लाओ रीमा, इसको ढक्कन ओपन इसको रख देना कायदे से. ओके. So what I want to mean is that, what I want to say is that this is light. Okay. This is flow of light. Now next figure it will be like that. Light here and the horizontal end shifted right hand side. Okay. Horizontal end shifted right hand side. In the next moment, light is represented by this. In the very next moment, light will be again represented by this. Okay. Total amount of energy, whether in circular part or horizontal part. Okay. Whether in circular part or left horizontal part. Whether in these two circular branches and horizontal part smaller, or this lower distribution and horizontal part. Total amount of energy, and this process is cyclic. Okay. This is cyclic trap of light inside this volume. Whatever volume is changing, as vibrations are here and this here, now here and here, but overall light content is same. Okay. This outer branch or side branches represent gravitational field. Okay. But horizontal part is here. Before it was never here, it was just outside here. So gravitational field is average of these all such horizontal parts. Okay. And this circular portion which is changing shape which is changing shape, actually represent atom. On an average sense, at any point, circular portion have same energy. At any point, at any instantaneous point, circular portion, whatever may be the shape, it has same energy. Similarly, side branch, whatever may be the shape, instantaneously have same energy. But gravity is all about average energy distribution. So we are saying that for gravity calculation, changing atomic space may be changed into some type of average space. Okay, and energy distribution may be given inside this atomic space, average energy distribution, and total energy is fixed, and around this average energy distribution situation is symmetric, and this average energy distributed because of circular flow of light, it creates gravitational field. Okay, this average energy E trapped inside this average volume is mass. Okay, and because of this average energy distribution, because of this mass, average distribution of energy gives gravitational field. So not only gravitational field, but mass and associated gravitational field, both are average phenomena. And but these are not instantaneous phenomena. Mass and gravity are not instantaneous phenomena. Instantaneous thing is this circular flow of light, where I am showing this figure, where energy distribution inside the atomic volume is changing. Okay, similarly atomic volume itself is changing, but at any instantaneous point, portion of light trapped in this circular region is exactly fixed, E, and portion of light trapped just outside this circular region is also exactly fixed, but instantaneous distributions are different. Quantum physics, that is atomic level physics, or Schrödinger wave function psi, R is distribution in space x, y, z and time, actually represent this instantaneous distribution of energy, in the instantaneous distribution of energy. So mass and gravity are average phenomena, but they come from instantaneous distribution of trapped light inside changing atomic volume and surrounding space, which is also varying. But on an average, overall, in terms of, but for gravity calculation, we have average volume, we have average energy E, uniformly distributed, and field is symmetrical, which is given in terms of average terms, and this represent mass, this average energy distribution around this average volume gives mass, property of mass, and average distribution in surrounding space gives property of gravity. Okay, but inside this changing volume, this volume is not actually fixed, it is changing, and so the distribution of energy is also changing. But of course, within this changing volume and changing with this changing distribution of energy is strictly conserved inside the atom, and this is symmetrical analysis. Gravity and mass are symmetrical analysis, but real analysis is quantum physics, which give real time changing variation of energy and volume. Of course, total energy is conserved at any point, but its distribution is given by psi in this changing volume. Okay, so how to connect these two things? Now we want to connect these two portions, these two things. So from instantaneous equation is given by Schrodinger equation or Dirac equation in relativistic term, or Bohr-Dirac equation, which we have developed. Now, so it may be anything. It may be given by, so distribution of energy is given by dV by dV t of psi is equal to for example minus h cut square by 2m, na double derivative of psi, na here I h cut you can have for complex analysis, but without complex analysis equation may be like dV by dV 2, now this is double derivative part, then you have without derivative part, that is ux multiplied by psi, and Dirac part also may be added, which is a spin constant multiplied by what, dV by dV x of psi. Okay, minus times multiplied by this is single derivative term, and multiplied by ux. Okay, so actually where psi is nothing but distribution of energy inside the atomic volume. So integral of mod of psi dV, or integral of, in complex terms, psi multiplied by psi star dV should be proportional to total energy inside the instantaneous or average volume of the atom. Whether instantaneous volume, changing volume, whether you see on average term of the atom, total energy is always E, and this since psi represents instantaneous distribution of energy or Higgs negative massless particles in our theory, so integral of psi multiplied by psi complex dV, it is actually a instantaneous summation, but it should be equal to total energy inside the atom, whether volume is changing or you are seeing in terms of average energy. that is proportional to total energy of the atom. Okay, now this thing should be proportional. This is total energy, and this should total in average energy is also same, instantaneous energy is same, average sense average energy inside the average volume of atom is same, instantaneous energy is also same with changing volume energy is same, but this should, all these things should be proportional to curvature of space time, curvature of space time. Okay, curvature of space time, and curvature of space time is given by tensor analysis or by general relativity. So psi can be calculated, where psi can be calculated by Schrodinger equations, Dirac equation, Bohr, Schrodinger, Dirac equation, any method. It gives instantaneous distribution of energy, and summation over this changing atomic volume should give instantaneous energy of the atom or average energy of the atom around average volume of the atom, and that should be proportional to curvature of space time, which is itself a average calculation, given by general relativity. So this is the way quantum physics and general relativity may be linked. Now further explanation I want to make is that psi in Schrodinger equation gives, you will say, give wave function corresponding to electron. No, but in our real terms it is distribution of negative massless particles, या Higgs negative massless particles. Okay, this is for one electron, and some these negative massless particles coalesce to form mass also. So a portion of psi is also present in mass also. Okay, and symmetry argument says that total energy in these Higgs negative massless particle or portion trapped in electronic mass should exactly be equal to total energy of the nucleus portion. Okay, so overall we can say that integral of psi star in complex term dV, it is negative massless particle distribution. Okay, but multiplied by some factor will give total electronic mass and negative massless particle distribution. Multiplied by K will give energy trapped in massless particle and energy trapped as mass because of coalescence of this massless particle. This is negative energy. Energy trapped in the electronic volume. But same energy should be present in the nucleus portion also. So multiplied by 2. All these factors will come to some type of correlation constant C. Integral psi star dV, and this should be proportional to or should give total energy of the atom, and that should be proportional to space, curvature of space time of general relativity. Curvature of space time is actually average phenomena. Is actually average phenomena. This is the way we can have a quantum gravity equation. For today's episode, this is my bakwas. I myself Manish Jaswal from our Kanya Chora Muttigai Prayagraj, UP, India, which is in equilibrium with, peaceful equilibrium with world. And I am thanking Rima Jaswal for her effort also, giving me pen, copy at any frequent time, random time. And I am thanking all the viewers, senior, junior, honorables also, and especially young minds from university and experienced and respected person from university. If they are seeing, this is just an idea to combine quantum physics and gravity. What energy conservation means in terms of atom, what it means in how energy conservation led to the property, average property of mass and associated gravitational field. Mass and associated gravitational field are average phenomena, but quantum physics provides the framework for instantaneous distribution of energy and of course mass inside the atom. How to link these two things? Instantaneous distribution of energy, which is given by wave function, and average distribution, which is given by curvature of space time by Einstein equation. How we can link these two equations? This is the way we can link quantum physics and general relativity. Thank you for watching the episode. I may be wrong at various steps, but this is how I am seeing the world. Thank you, sir.